Okay, this is the recording for the Unit 5 portfolio solutions. Again, as you watch this, you should have already attempted the Unit 5 portfolio and use this to check your work so that you have an idea as to what you may need to study as you prepare to finish out Unit 5. So, so the first question, you're told that the reflection of B, which is at negative 612, becomes B prime at negative 6, negative 12. So when we look at that reflection, um, we see that basically only the y coordinate has changed, which means this is a reflection about the x-axis. And if we reflect around the same line, we're going to reflect E around the x-axis as well. And when we reflect E around the x-axis, it's going to have the same overall effect in that the y coordinate is just going to change. So in this case, the image of E is going to be at 11, 8. As far as translations go, you're given these 3 points on a triangle, T, R, and H, and there's those coordinates. And you have a translation defined as basically x, y goes to x minus 1, y plus 4, which basically means each x coordinate in these 3 points, and therefore every other point in the triangle too, is going to get subtracted by 1, and that every y coordinate is going to be added by 4. So as we carry this through, negative 2 gets added, gets subtracted by 1, I get negative 3. 2 gets added by 4, I get negative 3, 6 for the image of t. For the image of r, again, I'm subtracting 1 from the x-coordinate, and that gives me negative 12 for the image, and I add 4 to the y-coordinate, which gives me 12 for the y-coordinate. And lastly, for h, again, subtracting 1 from negative 7 gives me negative 8. Adding 4 to negative 5 gives me negative 1. So these are the 3 points of that triangle, the image following that translation. After reflection about the line y equals x, the image point for C is at 9, 0. What's the original location of the point? Well, when I do a reflection around the line y equals x, what essentially happens, and we're saying the image is right down here, what happens, all that really happens is that I interchange the x and y coordinates. So this is like, 9 units away vertically, which means its image or its pre-image should be 9 units to the left up here. So, or I just switched the x and y coordinates essentially. So, since this one is at 9, 0, the original had to have been at 0, 9. And the whole idea about being reflected around this line here means that, when I draw this line, from one to the other, this line should basically be perpendicular to the line y equals x. I mean, because I'm looking at the shortest distance between it, and it's being reflected around, about that line. So, given triangle IDR with its coordinates at those 3 points, find the images of the points that the triangle is reflected about the x-axis. So, again, when I reflect about the x-axis, means that the y-coordinate is just going to change its sign. So, when I look at I is going to go from negative 5, comma, positive 10 to negative 5, negative 10 for the image. D prime, or the image of D, is going to be at negative 7, negative 12, because again, a sign change. For the image of R, I changed the sign of 0, it's still 0. And basically 10, 0 is on the x-axis, so if I'm reflecting about the x-axis, there's not going to be any change, anything that's already there. So that's why R happens to be its own image in this case. If the image of point H at 8, negative 3 is translated so that the coordinates of its image is at H prime 9, comma, negative 6, find the coordinate of the image of E if E is at negative 6, negative 3. So what I need to do is come up with a translation rule here based off of what I'm seeing as going from H to H prime. When I look at this, when I go from H to H prime, I can see that my x's got added by 1 and my y's got subtracted by 3. So that's the translation rule that tells me how I went from h to h prime. If I'm going to be using the same translation rule for e and e prime, if e is at -6, -3, and I apply that rule, if I add 1 to -6, I get -5. I subtract 3 from -3, I get -6. So the image of E would be at -5, -6. Given the triangle KMO has those coordinates, find the image of the triangle after a reflection about the line y equals -2. So y equals -2 is a horizontal line. Now, at times in the lessons I've shown drawings of this. You could also do this mentally. I mean, because basically, since it's a horizontal line, when I'm doing a reflection, I want to first find the shortest distance between it. So it's just going to be, how far above or below the line I am, and wherever it is with this line, I'm going to make sure I have a reflected image on the other side. So when I look at y equals -2, -6. +2 would be 4 units above the line y equals -2, which means its image should be 4 units below that line. So, if I'm at y equals -2 and move 4 units below that, it's going to put me at -6, -6. The x-coordinate, nothing changes. And that's going to be the same for the rest of them. The x-coordinate's not going to change for any of these. The only change is in the y-coordinate. So when I look at -11, 9, that's 11 units above the line y equals -2, so its image should be 11 units below the line y equals -2, which would put it at a y value of -13. So the image of M is at -11, -13. And lastly, 0, -6. Well, O at 0, -6 is going to be 4 units below the line y equals -2. So its image would be 4 units above the line y equals -2, which would put it at 0, 2. So your images would be at -6, -6 for K, -11, -13 for the image of M, and 0, 2 for the image of O. If point D, which is at 1712, is reflected about the point 7, 2, what are the coordinates of the image of D under this reflection? Okay. So when I'm reflecting about a point, which we don't discuss a whole lot, it's mentioned a couple of times, even in, just in small instances in these first 3 lessons in Unit 5. I basically am kind of like looking at drawing a line segment between my point and that point, and then drawing a line that's perpendicular to that. And, I basically just kind of measure, okay, well, when I look at D, it's basically 10 units to the right and 12 units up from 7, 2. So the image of it should be 10 units to the left and 10 units down from 7, 2. And so if I start at 7, 2 and move 10 units to the left, that would put me at -3 for an x value. And I move 10 units down, that should put me at -8 for the y value. So the image of D is at -3, -8. And for number 8, we have a point A at 8, -10. It undergoes the following transformations. It's first reflected about the line x equals 3. It then is translated according to the rule xy becomes x plus 2, y minus 5. And lastly, it's reflected about the line y equals -4. We want to determine the coordinates of the image of point A. So the transformation is actually in 3 parts. So I got to do one at a time, and it's important to know which order I'm doing them because the order does matter, which is why it's very direct in telling you which gets done first, which gets done second, so forth and so on. So if I reflect about the line 8 negative, if I take 8 -10 and reflect around the line x equals 3, now x equals 3 is a vertical line, and A is 5 units to the right of it, so its image would be 5 units to the left, and 5 units to the left of an x value of 3 would be a -2. So -2, -10 is where I would be after the first transformation, after the reflection. Now, if I use the transformation rule, the translation rule, it says x plus 2y minus 5, which means I'm going to take the x-coordinate, add 2 to it, take the y-coordinate, subtract 5 from it. And so when I do those two things, that's going to put me at 0, negative 15. Lastly, I'm going to be reflecting around the line y equals negative 4. So y equals negative 4 is a horizontal line. This point is 11 units below the line y equals negative 4, which means the point that I end up with should be at the same x-coordinate, but 11 units above y equals negative 4, and that would put me at 0, 7. So the image of A, undergoing these three transformations in that order, would put me at 0, 7 for the image of A. That's the end of this lesson. If you have any questions, please feel free to contact me. But until I get to talk to you on the phone or see you in live lesson, I will see you around. Have a good day.